Hello friends, in this video we'll talk about creating the SSL socket and the key store for the server machine using the Bouncy Castle as a custom provider. Now the steps to create the SSL socket and the key stores almost the same for the most part with creating the SSL socket and the key store for the client side, except for a few differences which I will explain them in this video. Now we are working on the server machine which uses Ubuntu 18.04 and JDK 8. So let's dive in. The first difference is that the class which we will use to create the SSL socket in, we will use a main method in it. This is the first class because the server will use, when it starts, will use this class, this main method to start the server. The second difference is that we need to create the file in here in this main method, the same that we have done with the client side, except that we will do it in the main method here, and afterward almost the same the same steps: the server key manager, trust manager, SSL context, SSL factory, SSL socket, almost the same for the most part, the same steps. So here the server key manager, we get the instance, we create the store builder as the utility class, which is again also the same as the ones that we have used in the client SSL socket class. And then we create the manager factory parameters and we initialize it, and then we create the key store and the certificate factory, all the same. And then we start storing the client key within the key store of the server. And once we have done this, then we could get the key managers by using the key manager factory and calling the get key managers method to get the key managers. So here we will store the client key at the server key store. Now if we do have another key we wish to use, then we just add it in here, the same thing, and we can add another key. For the trust managers, also the same that we have spoke about when we created the client SSL socket and key store, except the only difference in the client side, we store two things: the client certificate and the intermediate certificate, because we had to have them in the key store of the application side, of the client side. Now here on the server side, we could store other certificates, not necessarily just these two, whichever certificate we have, possibly the server certificate, possibly root chain certificate, any other certificate we could also save in here. Once we complete, and the saving procedure is also the same as what we have done before, which is this: when you store the client certificate, this is the same procedure that we have done with the client side. Now we will do the same procedure with the server side to save any certificate in the key store of the server. And once we have done the saving of the certificates, then we initialize it using the key store. Now remember again, if you have one certificate, in this case the intermediate certificate, then you can use directly the key store. Once you have initialized the trust manager factory, then you can call the get trust managers, which will give you a trust manager. And the rest, to initialize the SSL context, we use the key managers, first argument, trust manager, second argument, and third argument, which is the secure random. Now here's one difference comes, and the difference is this: the difference is this one. With the secure random, when we use the Bouncy Castle, we will not use, to get a secure random, we will not use the secure random class of the Java default security. We will use another class, a custom class called the DRBG, which is specifically designed for the custom provider of the Bouncy Castle provider. So this class, the DRBG class, will give you a more robust secure random that is specifically designed to be used with the Bouncy Castle provider. And this is the class, the DRBG class, and you can get it on the GitHub using this link. On the GitHub you can have it. This class has 3 static methods, 3 types of methods which can give you 3 types of secure random. Each one is stronger than the other one, so you need to use whichever one that's suitable for your case. The methods are, the static methods are set default DRBG, build DRBG, and build DRBG for keys. These 3 ones you need to read about a little bit so you can understand what is the differences between these and which one you can use with your application. I'm using this one, so I'm calling it, it's a static method, so I'm calling it using the class, and which will give me a secure random that is suitable for use with the Bouncy Castle provider, and I will use it in here. And here I will initialize the SSL context using these 3 arguments: the key managers, trust managers, and secure random. Once I have got the SSL context, then I will start initializing the server SSL server socket factory, cast it to SSL server socket factory. Then I use this instance of the server SSL socket factory to call create server socket, and I will use the same as previous video. We will use the 3 arguments: the port of your server, the logbag, which we said should be positive, more than 0, and the IP address of your server. And you need to cast it to SSL server socket to get an SSL server socket. Then the same steps exactly which we have done in the previous video. Once you have got your server socket, SSL server socket, that means your objective have been done and you got the server socket. The next step is that you need to create the thread factory, which can be after creating the server socket, SSL socket. And this creating the server thread factory is again the same as the previous video. Create a thread factory, thread pool, use the lambda, and deal with the create a socket for each and every request of connection using the accept method. Create the SSL server socket for it, and then use the way how you want to handle the data that's going back and forth between the client and the server, as we have mentioned in the previous video. And again, make sure that this class, whatever class you use, implements serializable. Don't forget that, because the data going over the internet should be serialized, should be binary form. And that's it. This is the way. As for the utility class, it's the same. What you need to do more is for each an extra certificate, you need to do the same thing. So if you have intermediate, you do it. If you have another name, root chain cert or whatever certificate, you do the same steps to save the certificate and to store it in the key store. That's it. That's a few differences between using the Java default and the Bouncy Castle to create the SSL socket and the key store on the server machine. Okay, thank you very much for watching.